Hello, I'm Jaimee and this is Alyssa, and we're here to teach you about series, sequences, and summation notation. First up is sequences. Sequences are an ordered list of numbers. An example of this is 1, 2, 3, and 4. Pay close attention to the commas in this. Arithmetic sequences are where the pattern adds or subtracts. This is an example of this because it goes up by 1 each time. So, geometric is when the pattern multiplies or divides. And for our examples, an example question is this sequence arithmetic or geometric? So, the sequence is 5, 8, 11, and 14. So first, you have to find the D, which is the common difference. So, how you start out with that is, if you start out by finding if it's arithmetic. So you find that by taking the second number and subtracting it by the first number. That ends up being 8. You do that with the next two numbers, which is 11 minus 8, which equals 3, and then 14 minus 11 equals 3. So you find that since all of these are the same, that means that your common difference, or D, is 3. And since you found it by adding, it means it is arithmetic. So, yeah. And then for the next example, it's the same question: is this sequence arithmetic or geometric? And the sequence is 25, 5, 1, and 0.2. So you start out by seeing if it's arithmetic. So you take the first or the second one, subtract it by the first. That equals a negative 20. You do that with the next one. So 1 minus 5 equals negative 4. Since those are different, you know that is not arithmetic. So you start out by trying to see if it's geometric. You take the first one and divide it by the second one. That equals 5. You take the next one, divide it by the next one, and then that equals 5, and then 1 divided by 0.2 equals 5. Since all these are the same, you know that is the common difference, or D. And since you found it by dividing, it is geometric. The next example, this one's a little bit trickier. You have to find the 10th term in the sequence. So, the sequence is 3, 5, 7, and 9. You have to start out by finding the D. So, you have to take the second one and subtract it by the third, and that equals 2. And then take the next one, subtract it by 5, that equals 2, and then 9 minus 7 equals 2. So you find that that's a common difference, and okay. And then, so, next thing you do is you have to take the, oh my god, so you found the D, which is 2, and then you find A of n, which is the term you want to find, so that's 10, because that's the term that it tells you. And then you have to find A of 1, which is the first term, which in this case is 3. And then, you have to use the arithmetic sequence formula next, which is A of n equals n, or A of 1 minus plus n minus 1 times d. So you found a of 1, which is 3, because that is the first number, and then you add that in n, in this case is 10, and you subtract that by 1, and then you use d, which is 2. So you just solve for it. So you do PEMDAS, so you start with parentheses, so 3 plus 9 times 2, and then multiplication comes next in PEMDAS, so you do 9 times 2, which is 18, and then you add 3, which ends up being 21. So that is your answer for the 10th term. It is 21.
Next, we're going to learn about series. A series is the sum of the sequence. For example, the sequence is 1, 2, 3, and 4. The series of that is 1 plus 2 plus 3 plus 4, which is equal to 10. Another example is 3, 6, 9, 12, 15, and 18, which is the sequence. And the series is 3 plus 6 plus 9 plus 12 plus 15 plus 18, and that is equal to 63. The next example is the sequence is 5, 8, 11, 14, and 17 and 20. And the series is 5 plus 8 plus 11 plus 14 plus 17 plus 20, which is equal to 58. We're going to learn about summation notation. So, this little Eve looking thing here, you would say the sum of, and then, yeah. So the number up top is the last value of n. The problem right here, or the formula right here, is the formula for the terms. This number down here, this is the index, and that's the first value of n. So, for example, n equals 3, so that we'll start with the number 3 in the we'll plug this number 3 into the equation. And we'll go up through the numbers until this number, which is 7. So we're going to go 4 times 3, which is equal to 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, and 4 times 7 is 28. And then to find the sum of this summation, you would do 12 plus 16 plus 20 plus 24 plus 28, which is equal to 100. So you would just take the series and, yeah, that's your answer. Another example is, so n equals 1, the last value of n is 6, and the equation is 3n plus 2. So, you're going to start off with 3 times 1 plus 2, which is equal to 5. Then you're going to do 3 times 2 plus 2, which is 8. 3 times 3 plus 2, which is 11. 3 times 4 plus 2, which is 14. 3 times 5 plus 2, 17. And 3 times 6 plus 2 is 20. So, you're going to take the series of the answers right here. So 5 plus 8 plus 11 plus 14 plus 17 and plus 20. And you're going to add them all up, and that's equal to 75.